Hello everyone, this is Hurang. If you watched my previous video on IP telephony in Packet Tracer, there I showed you how to configure IP phones in Packet Tracer, but there we had a very small network of 3 IP phones. In this video I decided to come up with a new topology, add data to our network, so we have a combination of data and voice network here. And as you can see in this topology, I've added a server to play the role of DHCP server for me instead of a router. So I'm going to show you how to configure this network and with one DHCP server to serve both voice and the data VLAN. So if you look at this topology, here I got 2 IP phones, and these IP phones are in voice VLAN, and as you can see here, I put them in this pink oval. So pink represents voice VLAN and blue represents data VLAN. So wherever you see this blue, it means that device is in data VLAN. As you can see here, I have 3 computers and I have a DHCP server. I have put all of them in data VLAN, and I got a router here that plays the role of communication manager. Make sure that you choose this 2811 router because this is the only one that supports voice and communication manager configurations in Packet Tracer. Let's go through this configuration and see how we can configure all this stuff in Packet Tracer. I'm going to begin this configuration with the switch. So here is, we go to global configurations, and the first thing that I'm gonna do is creating the 2 VLANs that I have. One is for voice and the other one is for data. So VLAN 5 is for my voice, so name will be voice, and VLAN 10 is gonna be for my data, so I'm gonna call it data. And so I created these 2 VLANs. Now I'm gonna assign ports to these VLANs. As you can see here, this is fast Ethernet 012, 02, 11, and 10. So all these ports must be assigned to data VLAN. But the question is, these phones are also connected to these ports that I'm going to assign them to data. So how these guys are going to be in different VLANs. So for that one, I'm going to show you how we can do that. Okay, so, and one more thing, this interface here is going to be a trunk interface because that's connected to the router. So interface fast Ethernet 0/1, this interface will be trunk, so switchboard mode trunk, and that's the only interface which is trunk here. The rest of the interfaces, so interface range fast Ethernet 0/2 to 24 are going to be access ports, so switch port mode access, and switch port access VLAN 10, which is my data VLAN. Okay, so all these interfaces that I'm using and I'm not using are assigned to VLAN 10. So what do I do for these 2 interfaces, interface 10 and 11? For those 2, I'm gonna exit this range here, and I'm gonna go to those 2 interfaces. So interface range fast Ethernet 0/10 and 11. These 2 interfaces gonna be part of switch port voice VLAN 5. These 2 are part of voice VLAN as well. So if I type show run here, you can see all interface except this first interface, which is trunk. The rest of interfaces are part of VLAN 10, right? When you come to interface and it comes to 10 and 11, you see both of them are part of VLAN 10, and at the same time both of them are part of voice VLAN as well. So that's how you can assign an interface to be part of voice and data at the same time. Okay, so I think I'm done with the configuration of the switch. Next thing that I'm gonna do is the router. This router will be the gateway for voice and data. So since it's one router and here I got a trunk interface, it means this router will be a router on stick. So we have sub interfaces here. One of the sub interfaces will be a gateway for voice, and the other sub interface will be a gateway for data. So let's go to global configurations. First thing that I'm gonna do is go to console, line console, and then type no exec timeout, because I don't want to get timeout if my session is inactive. Now the second thing that I'm gonna do, change the name of this router to CUCM so that I know this is the communication manager. Now first interface, fast Ethernet 0/0. Interface fast Ethernet 0/0. This interface is the one that is connected to the switch. The only thing that I'm gonna do under this interface is no shot. I just bring that interface up. I'm not gonna assign any IP addresses to that interface. Then exit from that interface. Now I'm gonna create sub interfaces. So interface fast Ethernet 0/0.5. This interface is gonna be my gateway to the voice network, voice VLAN. So the encapsulation for this interface will be .1Q, and it's for voice VLAN. The IP address is 192.168.1.255.255.255.0 is the subnet mask, and that's all. The second sub interface is 0/0.10, and encapsulation will be .1Q for VLAN 10, and the IP address is 192.168.10.1.255.0, and that's all for the interface configuration for this router. Okay, so I'm gonna leave this router. I'll do the rest of the telephony configurations later. Next, I'm gonna configure this DHCP server. So this DHCP server is going to serve both VLANs, both voice and data VLANs. Okay, first I'm gonna assign an IP address to that. So 192.168.10.2. As you can see here, I'm gonna put this DHCP server in data VLAN. So all computers in this network have no problem reaching this DHCP server. The only problem will be this phone. That I'll show you how we solve that problem as well. So we assigned IP address to this DHCP server. Now to configure it, we go under config and look for DHCP tab here. As you can see, click on it. Now in packet tracer, DHCP server by default has one pool configured. I'm gonna modify that pool. This pool, I'm gonna configure it for data VLAN. So 192.168.10.1 is the gateway for data VLAN. We don't have a DNS server. If you had one, you could put assign the IP address here, but since we don't have it, I'm not gonna use any IP address there. Start IP address 192.168.10.1 is used for the router. The second one is used for the DHCP. I'm going to start from 5. So the first 4 addresses are reserved. And TFTP server, for this data network, I don't need a TFTP server. I'll explain what that TFTP server is when I'm configuring a pool for voice network. Okay, so that's all. Save this. The second pool that I need is the pool for voice VLAN. So I'm gonna call that voice pool. The IP address of the default gateway is 192.168.5.1. No DNS server. And I'm gonna start from 5.5 here. And here I need a TFTP server. Why do I need that? Because when you start your phones, these phones will, let me get my pen. When you start your phones, these phones, both of them are gonna go to DHCP server, right? Now I'll explain how later. But now they're going to DHCP server. They say, okay, give me an IP address. The DHCP server is gonna give them an IP address. So respond them with an IP address, both of them. Then at the same time, this DHCP server is gonna tell them, hey, your TFTP server, meaning the guy that you need to refer to download your firmware, is this particular IP address. So in this case, my TFTP server is this router. So I'm gonna assign a put the IP address of TFTP server here. When the DHCP server responds back with the IP addresses for these IP phones, it will give them the address of the TFTP server and tell them to download your firmware, refer to that address. So when the phones get their IP addresses, they look at that TFTP and say, oh, okay, so I gotta go to that TFTP server to download my firmware. Okay, so let's go back to that DHCP server. Now, as I explained, the TFTP server in this case will be your communication manager, which is my router. So 192.168.5.1. That is the default gateway, and at the same time the TFTP server for the voice, for all those IP phones. And I'm gonna add this as well. So now we got 2 pools. The first pool, 192.168.5.1 for voice, everything is okay here, and the second one is for data, and everything is okay here as well. Okay, great. Now let's see if let's try and see if my DHCP server works fine. I'm gonna go to this computer, and here IP configurations, and I'm gonna choose to receive your IP addresses from DHCP server. As you can see here, 10.5 is assigned to this computer. That's great, so it works. But if I start my phones, it won't work because these phones are in different VLANs, so they won't be able to communicate with this DHCP server. So for these phones to be able to communicate with this DHCP server, I have to go to this default gateway, the router. I'm gonna go under the interface fast Ethernet 0/0.5, which is the gateway of the phones. And I'm gonna type IP helper address 192.168.10.2. And that's it. With this one line, now my phones are able to communicate with the DHCP server. Let's see how. When you start this phone, both of these phones send a broadcast requesting for an IP address. So these broadcasts, for example, let's work on this phone. This broadcast that comes from this phone goes to this switch, and this switch is gonna send it out of all interfaces in that VLAN. So in this case, it goes out of this one, but not this one, not the one that it has come from, and this one, because we have one interface from this router that goes to this VLAN, right? So it sent the broadcast to these two interfaces. Now the broadcast will get discarded here because this guy has no idea what that request is. The other one goes here to the router. Now, if I had not typed that line in that router, the router would drop that broadcast request. Why? Because that's the job of a router, right? Router drops broadcast. It stops broadcast. But since I have typed that line, IP helper address, now this router is not gonna drop that packet. This router is gonna take that request, which is a UDP request, and look at that helper address. The helper address was the address of 192.168.10.2, which is this DHCP server. Now, the router is going to send that packet as a unicast to this DHCP server, right? Now, when DHCP server receives that request comes from a VLAN, which is from this subnet 192.168.5 dot something, because the router received that request from the interface 192.168.5.1, and then it sent it as a unicast to this DHCP. Now when DHCP receives that request, and that request is from this subnet, then it's gonna look at the pool that it has for voice. Now let me bring up our pools and delete all these lines here. Okay, so our DHCP, you look at here, we have two different pools. So DHCP doesn't know which pool it has to use. Based on the request that comes, DHCP assign one IP address. Now when the request comes from the router and it's from this IP address 192.168.5.1, then DHCP server is gonna look at this pool. It says, okay, I got here a pool which has 5 dot something, which belongs to 192.168.5.0 subnet. So I'm gonna choose an IP address from this pool, and it responds back. Let me change the color. Now it responds back with that IP address to the router as a unicast. It says, there you go, the IP address, the request that you sent for an IP address, here is the IP address. Now the router responds back to that broadcast request that came from this IP phone. It says, there you go, this is the IP address that you requested. So that's how an IP phone from a voice VLAN, different VLAN, can communicate with a DHCP server which is in data VLAN. With that one line that I wrote on this router, that line was IP helper address and the address of DHCP server, which is this guy. So you can always do that if you want. This IP helper address works for other protocols as well. It can work for like other UDP supported protocols, which you can try for yourself if you are interested. Okay, so let's continue. Now let's start a phone and verify if this phone can receive an IP address from that DHCP server. To start a phone, click on it, and then you got a cord here, drag and bring it here on this connector on the back of the phone and release it there. Now the phone is started and it's coming up. We'll do the same thing for the second phone. Now it might take few minutes for those phones to receive their IP addresses from DHCP server. It won't be as fast as the PCs that they have here in the picture. So for these phones, you might need to wait few minutes. So I'm gonna pause my video for a few minutes, and then when these phones receive their IP addresses, I'm gonna come back. Okay, now my phones received their IP addresses, It took me about like 1 to 2 minutes to get these IP addresses, like for the phones to get the IP addresses. Now, next I'm gonna click on these two PCs and configure them to receive their IP addresses from DHCP server. This is the first one and the second one. So everyone's got these IP addresses. Now let's go and configure our communication manager. Click on the router. The first thing that I'm going to do is on global configurations, type telephony service. Enter. Now you are under config telephony of the communication manager router. Here I'm going to run three commands. The first command that you run is max dn. You're going to configure maximum number of directory numbers. It's like you have a phone book and the number of phone numbers that you're going to put in that book. How many phone numbers you're going to put in that book. So in this case, I'm going to say like we're going to have like 20 different numbers. Second command is max ephone. How many ephones, physical phones you have in your network? In this case, we only have 2 ephones. So I might have some more phones later in future. So for future expansion, I'm gonna say like maximum number of ephones will be 10. And the third command that you have to type here is IP source address 192.168.5.1. This IP address is in fact the IP address of the default gateway, but this default gateway plays the role of communication manager as well. So this IP address tells these phones that your communication processor is this IP address. For any communication, you gotta refer to this guy to process your communication for whatever. That is the brain. So refer to that guy. And then use a port, whatever port that you want to do. Put there like 2000. So this one line tells those phones to use port 2000 and communicate with this IP address for all the communication processings. That's the brain. That's all that I configure under telephony service. Exit. Now I'm gonna assign these I'm gonna assign a number to these directory numbers that I have, right? I have 20 directory numbers, 20 phone numbers. I can have 20 phone numbers in my directory list, directory numbers. So the first ephone dn. So ephone dn1. This is the first spot empty block in your directory list. Number is, for example, 5001. Then ephone dn2. The second directory number is 5002. ephone dn3. Third directory number is 5003, and so on. So since I got only 2 phones here, and these packet tracer phones are single line phones, they're not dual line, so that you can assign different phone numbers to one phone, different phone lines. You can only assign one phone line to each phone. So configuring these 3, I think, will be sufficient for our purpose here. Exit. Now we have 2 phones here. I'm gonna assign these phone numbers to these phones. How do I do that? First, let's see if we have any ePhones here. Show ePhones. Look at these phones. They are already registered with the communication manager. Here is the MAC address of the first one, MAC address of the second one, but they don't have any IP address or number. So what I'm gonna do is go to global configurations. I type ephone 1 button 1 colon 1. Now what this means, I'll show it to you shortly. Let's go to this phone's GUI mode. As you can see here, I already assigned that IP, phone number to this guy. Now if you look at here, we have 1 2 3 4 5 6 buttons. So this is button 1, button 2, button 3, 4, 5, 6. In a real world, I can assign 6 phone lines to this phone. Line 1, line 2, 3, 4, 5, 6. But in Packet Tracer, as I mentioned before, we can just have one phone line. So what I configured, oh, let's have this in picture. What I configured here was this. I set ephone 1, meaning my first phone. Button 1, meaning this button, will have the first phone number, the first number in my directory numbers, which was 5001. Let's do that for the second phone. ephone 2, button 1 colon 2. The button 1 of the second phone will have the second phone number in my list, which is 5002. This is your second phone number, right? In the directory numbers that you had. Enter. That's all. Now if I type show ephone, here I see I have 2 phones. This is the IP address of the first one, IP address of the second one, and this is the phone number of the first one and phone number of the second one. Okay, we had this first phone open. This is the second phone, and 5002 is the number, the second number. So if I click on this phone and dial 5001, you can see here the second phone is ringing, and answer the phone, and you can see here the phones are connected. So that's how you can configure a network of voice and data with one DHCP server in Packet Tracer. I hope this video is helpful and you like it, and thank you for watching.